On to Explore Classroom. My name is Gina Borgia, and I am so glad you are joining us today. Many viewers around the world are celebrating Ramadan, and we want to wish you all a beautiful celebration. At National Geographic, we know the power of exploration, wonder, and storytelling can change the world for the better. This Explore Classroom YouTube show connects students around the world with our National Geographic Explorers for short lessons and time for your questions. Today, our explorer is Rachael Miller. Rachael is a conservationist who focuses on protecting the ocean and keeping it clean, especially from microfibers. Microfibers are tiny pieces of fiber, often coming from our clothing, that are getting into the ocean. They are so small that it can be hard to see, and they end up being eaten by ocean animals, which is not good for their health, our health, or the health of the ocean. Rachael and her team invented the world's first microfiber-catching laundry ball and is working with her team at Rosalia Project for a Clean Ocean to create new ways to help more people protect the ocean from microfibers. Before we get into today's lesson, let's welcome our viewers who registered in advance and are joining us today from around the world. Our shout outs for today go to 191 Virtual, Anna McDonald Elementary, Masonville Public School, the Discovery School, Geraldine W. Johnson School, Norton Park Elementary, Whitehead Homeschool, International School Basel, Ocean Breeze, Norton Park, Taylor Elementary School, Heritage Elementary, Eisenhower, Eugene School District 4J, Jessie May Monroe Elementary, Ascension Episcopal, Hillcrest STEAM Academy, International School of Florence, Rensselaer Park Elementary, Cienzo en El Huerto, Coppell Middle School North, Maddock Academy, Samoa Baptist, Hanover Elementary, West Rutland School, Olympia High, Barker Middle, Hilltop Elementary, Oakland Elementary, Logan Rogersville, John Adams, White Oak, North Shore, St. Bede the Venerable, R. Ross Beatty Public School, CMK Homeschool, Felix A. Williams, and all of our homeschools out there. We are so happy to have so many of you joining us today. And with that, let's get this Explorer Classroom started. It's time to turn it over to Rachael to share all about microfiber pollution and solutions. Take it away, Rachael.
Thank you, Gina, and hello, students all over the world. Now, let's see, who loves the ocean? It sounds like there are people who are all over our one big ocean. I do, and I bet there's some people who love some lakes and rivers too. Well, my job is to protect our ocean, lakes, and rivers, and I do that through expedition science, through engineering and innovation, and by teaching and raising awareness. Now, my team and I work on all different parts of the marine debris problem, the ocean trash problem. But I'm going to start talking about one that you may not have heard of, because this is one that you can't see while you're standing on the beach. And it has to do with our clothing. So have a look at what you're wearing. Just have a look. It probably looks like one big piece of fabric. And while it is one big piece of fabric, the reality is that our clothes are made up of millions of individual fibers woven together. Long fibers, usually, sometimes medium-sized. But I'm going to share my screen and show you something that you might not have seen before. Now, you certainly have seen a pair of jeans before, but have you seen a pair of jeans magnified? When you put jeans under a microscope, what you'd see with your naked eye as a thread, which is sort of one of those blobs, is actually made up of thousands of tiny little fibers. Now, that's a good thing. It makes your jeans soft and even strong. But the ends of those little fibers, they can break. They could be fragile now that you see how small they are. Now, here's a fleece dress. I live in Vermont. We wear fleece dresses. And here's a fleece dress magnified. Check that out. Now, the situation is that this breaking of fibers off of our clothes can happen multiple ways. It happens in washing machines, it happens in dryers, and it happens while we wear clothes, like my friends in Indonesia doing a beach cleanup while wearing clothes. Now, our team has primarily worked on the part of this problem that is related to washing machines. Now, think about a washing machine. Think about a garment. You take a shirt, you ball it up, you drop it in the machine, you put in some soap, and then there's water, and then it spins, and then more water, and rubbing up against other clothes. It's a pretty rough place. And while all that's happening, these little bits of fiber can break off. Now, you don't see it happening because it's happening slowly. We call it microfiber because usually you can only see these little pieces with a microscope. And to give you some scale, I want you to think of a grain of rice, one individual grain of rice. There's a bunch here in a pile. So those are little rice grains, and you see a bundle of fiber. Look how small it is compared to something that's already small. And it's even small compared to things that are smaller than rice. These are salt crystals, obviously under a microscope, and the fiber is even smaller. These are the pieces of fiber that broke off of clothes in the washing machine. This is happening at a large scale. Little pieces, large scale. Scientific studies have shown that one shirt could shed over 700,000 individual tiny microscopic pieces every time it's washed. And the pieces are so small that the filters that appear on washing machines, there's not even very many washing machines with filters, their holes are too big to stop something this small. And so the microfiber can end up in our public waterways. And there's fish and creatures there, and they ingest it. And if we eat fish, there's a potential that we eat what they eat. And so the microfiber can pose two types of dangers to those creatures. One is physical danger. This would be like having an injury. It can include like scratching a little tiny throat or filling up the belly of plankton with something that isn't giving them any nutrition. There's another danger, and that's chemical danger. This is related to something being toxic to an organism or similar to being poisoned. Now, remember we said what they eat, we might eat. And there was an investigation where scientists went to a fish market in California, and they got fish and shellfish and they dissected them. And they found that 1 in 3 shellfish and 1 in 4 of the finfish had microfiber in them. And these were fish that were at a fish market. Over 220 species of marine creatures, including seabirds, have been shown to have microplastic, mostly microfibers in them because of ingestion. And it does not just stop with our sea creatures. Microfiber has also been found in tap water, in bottled water, in honey, salt, and beer, which you don't need to worry about yet. But I have to say that when we heard about this problem, it was a problem that I say screamed at us. It didn't just whisper or speak to us. When we learned about this problem, we just set 3 goals. And those 3 goals were to first, learn everything we can about the problem of microfiber pollution and even see if we could discover new information, because when we learned about it, it had only been discovered 2 years before. We've been doing that through expedition science. We wanted to develop a solution, and I can't wait to introduce you to our solution. And we wanted to inspire new ideas and innovation from people in other industries and to raise awareness in people of all ages to help work on the problem. So let's look at the learn new knowledge and make new discoveries side. We did that by asking the question, what does microfiber look like in the wild? And we decided to take our 60-foot sailing research vessel, and we also had to use our feet, and you'll see other methods in a moment. And we sampled the entire Hudson River. The Hudson River is in the Northeast United States in the state of New York. It has mountains up here in the northern part of the state, and that's where the Hudson River starts. These dots represent every sample location as we started in the Adirondack Mountains, and we sampled our way south and downhill and down current all the way to Ambrose Light, where the Hudson River meets the Atlantic Ocean. We took samples from the surface of the water using a metal bucket. We took samples from the air using a little pump. So I'm pulling the pump down from the mast on American Promise. That's the Statue of Liberty behind me. That was a really fun day. And we took soil samples too, to see if maybe microfibers were falling out of the sky or part of runoff. Okay, now those of you who've been able to travel a little bit on a river will appreciate this. And those of you who haven't, I'm going to take you down the whole Hudson River. Here's where the Hudson River starts. These are all of the sample locations. We're moving south. We had to do some of our samples from whitewater raft because it allowed us to get 4 in one day instead of doing 4 really, really long hikes. That was fun. Whitewater rafting for science. Here we go. We're heading through the canals on the Hudson River. We could take American Promise to about the halfway point. So now we're back on American Promise, heading south. The rule for our sample photos was that no two could be alike. So that explains some of the poses that you'll see. And it was really hot. So sometimes we had to jump in the water to do our sample photos. There's Manhattan in New York City, the Verrazano Narrows Bridge, and Ambrose Light. That is the place where the Hudson River officially meets the Atlantic Ocean. And here's microfiber from the wild. We are taking the information that we learned from these expeditions to inform and strengthen our own solutions. And we are publishing our results in peer-reviewed journals so that engineers and scientists all over the world have access to this information as well. And now I can introduce you to the Cora Ball. This is our solution, a solution to microfiber pollution. It is a microfiber-catching laundry ball, and it goes in your washing machine. You just drop or toss it in, and it works with, not against your clothes, to collect these microscopic fibers that might be breaking off your clothes. And you can see that if they're breaking, when they break off your clothes, they'll just float around in the water. And the Cora Ball helps tangle them together and collect them. The tangling together part is important because this is what it looks like. They end up in a little fuzz ball. And this fuzz ball with just your naked eye looks kind of like just hair. But what's really incredible is when we put a digital microscope on it, what we see is that that fuzz ball is actually little tiny bits from lots of different articles of clothing. And again, there are lots of those bits, but with our naked eye, all we can see is a little bit of gray fuzz. Now, I have to say that all of our attempts to design a solution to microfiber pollution didn't really work. So the process of innovation and invention and even science itself requires having an idea, testing that idea, usually having it not work, learning from the experiment, making adjustments and moving on. And so when our initial attempts weren't really working, they were breaking in the washing machine or they weren't really catching much, what we did was we simplified the question. We couldn't just say, how do we catch microfiber? Because no one had really done that before. What we did was we said, we need to catch small things from moving water. And we thought about it and we realized coral catches small plankton from moving water. It's stuck to a rock. It can't swim around and get food. And so we realized that our inspiration could come from the ocean itself. And the Cora Ball was born from the very idea of coral. And this was what came out of realizing that we could use a process called biomimicry, which is copying nature, to design our microfiber catcher. But it still wasn't ready. We then ran into another challenge. This is 3D printed, and it takes 3 days to print all the pieces. That's not very efficient for trying to get them in as many washing machines as we can. So we had another now engineering challenge to adapt the design to what it is today, where now the Cora Ball is helping prevent microfiber pollution in washing machines in over 62 countries. So you can all be part of solutions to microfiber pollution specifically different ways. It's not just the Cora Ball, but you could also only wash clothes that are dirty. So do less laundry. Do wash your dirty clothes. That is important. But if you only wear something for like between dinner and bedtime, Maybe it doesn't need to be washed. Using cold water reduces shedding, and also doing full loads reduces shedding. And one thing I also didn't say is the Cora Ball itself, in addition to tangling up the pieces, also helps reduce shedding. But now that we're talking about solutions, I want to finish up by sharing some of my favorite. We're going to go fast. So if we want, we can talk more about these in the question period, but I am excited to share what we have here. So get ready. Here we go. One solution is to work with people from other industries and other academic subjects. It turns out that crime scene investigators have very advanced knowledge in fiber forensics. They need to know where a fiber came from, if it's the carpet in the house. People's lives depend on it. And we teamed up with a team of fiber forensic experts, or forensic fiber experts, to bring their techniques to the ocean. Art can be a solution by reminding people that storm drains are connected right to the bay, river, or lake in a really fun way. We also have marine debris art can be a potential solution, reminding people of what's out there. There's a great artist called Cindy Pease Rowe, and she made this beautiful whale, but it's all trash she found on the beach. And she even trained us to make funny little whales out of trash that we found from the beach. Regulation and policy are types of solutions, and this is happening in countries worldwide. Innovation and redesign, like these straws that are made out of algae. We can have innovation in technology, like an app called the Marine Debris Tracker. So people who are doing beach cleanups everywhere can use a free app. And when you collect data, when you do your beach cleanups, it makes your beach cleanups count more because we know what's out there, and then we can work towards solutions. Sometimes solutions happen after you go surfing. 3 friends went surfing in South America. They learned about problems with big fishing nets and what to do at the end of their lives. They realized that's valuable material. And now their company, Borreo, is making skateboards and sunglasses out of something that used to be a big problem. It can be smaller, but really cool ideas like replacing plastic stirrers with spaghetti. We also have infrastructure solutions. What if you had a river or a canal, like in Amsterdam, where you need fish and ships to move, but there's a lot of trash and stuff that can't really swim that needs to be diverted? Well, a team figured out they could make a bubble net. You know who else makes bubble nets? Humpback whales. So this is another form of being inspired by nature. So the bubbles rise up, they divert the stuff that can't swim, boats and fish can get through. Then there are rivers where you can go ahead and block the river and collect incredible amounts of trash. These are in Baltimore, and now they're popping up all over. It's called Mr. Trash Wheel, and there's a lady, Professor Trash Wheel, around the corner in the harbor. The moving water from the river spins the paddle wheel. That turns the conveyor belt. The booms put the trash in there. And all these things are what was caught in 1 year of this kind of passive collection. I love it. And finally, science inspires solutions. It can be a solution unto itself. A National Geographic Explorer, Jenna Jambeck, was the lead author of a very important bit of scientific knowledge that said, these countries around the world where the most trash is washing off their shores. There were more, that itself inspired more information like this one, where it shows what rivers specifically are causing the most trash to enter our world's one big ocean. And that was heard. This is the Minister of Marine Affairs in Jakarta, Indonesia. And let me zoom in on his slide. They said, we're a beautiful island country. We can't be known as someone who's has a trash problem. We got to clean it up. And so that before picture is all trash. And the after picture on the bottom, that's the same river, trash free. You can be part of science that inspires changes around the world by getting excited about learning about the ocean, or maybe you're engineering focused and you can see potential solutions. Whatever you do, know that it counts. So thank you for protecting our one big ocean, lakes and rivers, And I hope that you'll remember something that I believe, and that is that lots of little problems can add up to a big problem. Think of microfiber pollution, but lots of little efforts add up to big impact. I am really, really excited for our question period. And I know you guys are getting revved up thinking about your questions. So while you're doing that, I would like to say one last thing, and that's Happy National Dolphin Day.
Wow, that's pretty fabulous. Thank you for sharing that story with us. Okay, Rachel, we have one last question here for you, and we want to know, how can we take on your mission and help reduce and stop microfiber pollution?
I love it. This is a great way to wrap up. So I just want to remind everyone that in addition to things like the Cora Ball, you can take action to prevent microfiber pollution by doing less laundry, which means washing the clothes that are dirty, but not just washing everything that you ever put on, making sure that the clothes that go in the hamper are dirty. You can air dry when it's possible, not all the time, like we can, like in Vermont, it's sometimes just snowing and we can't put our clothes outside. But you can wash with cold water and do full loads. The clothes rub against each other less when the washing machine is full. In addition to that, you can share this knowledge with friends and parents and colleagues and continue to know that lots of little efforts make a big impact.
Thank you so much, Rachel, for sharing all of that and for sharing your entire story and about your work with us today.
Thank you for having me. Thank you for your attention, everyone. I love that we get people from all over the world participating. It's awesome.
Yes, and thank you to all the students out there for your thoughtful questions, and thank you to the teachers who make this happen for your students. I hope you join many more of our events. Next week, we have an extra special lineup for you to celebrate Earth Day. We'll hear from explorers João Campos Silva, Andresa Scabin, and Hinsby Cadillo Coros, who are all part of the all-new National Geographic Society Perpetual Planet Amazon expedition. This is a 2-year series of scientific studies spanning the entire Amazon River basin. And next Thursday at this time, we'll learn all about the impacts of pollution, mining, and deforestation in the Amazon from Hinsby. And in the afternoon, we'll learn about the aquatic wildlife from João and Andresa. Then on Friday, we have a special event at 2 p.m. Eastern to learn about the importance of community conservation in the Amazon to celebrate Earth Day. So you can register your student group for a shout out during the event and a chance to be on screen with us at natgeoed.org/Explore Classroom. We hope you have a great day, everyone. Stay curious and keep exploring. Thank you so much, and we'll see you soon. Bye.